Hello and welcome to the Daylighting in LBTools series. In this video, we're going to review two ways to add a grid of test points for daylight modeling. Test points are required because the Radiance engine will use backwards ray tracing from each sensor point that you add to your model to find the sun and give you an indication of how much daylight can actually reach that point, that sensor grid that you set up. So suffice it to say, sensor grids are an integral requirement of daylight modeling, and LBTools supports two different workflows similar to the two geometry setup methodologies that we used, and they're interchangeable. So let's get to Grasshopper and get started with adding a sensor grid. So I'm starting with the same script that we worked with in the Add Shades to Aperture video, and we still have the room from solids from the Create Geometry video. And what we're going to do is we're going to see two different ways of adding sensors. The easiest one is to actually start with the room from solids. And to add a grid, we're going to switch to the Honeybee Radiance tab to add the sensor grid. Okay, so we want to go down to, we don't want to use HB sensor grid because that is not tied to rooms. We're going to use the Honeybee sensor grid from rooms for this workflow. So we'll drop that down. And what we're actually doing is we're just taking the model and connecting it to the room's input. And then we have to give each grid a size. So the grid size is tied to the units that you're using in Rhino. So you can check. So my Rhino is set to meters. So whatever number I put in my Grasshopper script, it's going to align with the grid size of that room, the units in Rhino. So I might start with a 1 meter by 1 meter grid size. And then the next input is the distance off the floor. So when you're using the room workflow, it can add it right at the floor, or you can offset it. And for daylighting, typically we use around 30 inches for a worktop surface, which is roughly 0.7 meters. So I'll add that in. That's all we need to do. Let's go to our Rhino space and see what preview that grid. So if we turn off, so there's a draw preview only for selected geometries, we can preview our grid of points. Now, if you're doing a small space, if you're analyzing a small space, this might be an appropriate spacing, but if this was a huge 30,000 square feet warehouse space, you may want to increase the spacing. So you might do a slider that's much wider. So now not very good, but you can connect the slider and see what that spacing looks like before you analyze it. The more points you have, the longer the study takes. The fewer the points you have, the faster the study will be. Okay, and then that's all you're adding for the room when you have rooms already set up using the HB room from solid workflow. The second way to create a sensor grid is actually a little bit more flexible. So say you don't want to test a whole room, right? You don't want to test the entire volume. You just want to test a certain portion of a room. So you can start by drawing a surface in Rhino that replicates about the approximate area that you want to test. So I'm just going to create this geometry. And this is the area that I want to test. I don't want to test the whole room and run a really long study. I just want to do a quick study only in the daylit zone. So I'll go back to my Rhino. And in this workflow, you're going to want to create a geometry, right? So you'll bring down a geometry component. And I already have one here that I've named Analysis Grid. And I'll set it to that one surface. And then once you've connected it to the geometry parameter, what you want to do is bring down the Ladybug Generate Point Grids, which can be found in the Ladybug tab. It's in the Extra section under LB Generate Point Grid, and you'll connect that geometry to the input geometry, and you'll also give a grid size and an offset distance. So 0.762 is the more accurate representation of 30 inches in meters. And once you've assigned the grid size and the offset distance, what you'll do is you will connect that analysis grid to the HB sensor grid component, which if we go back to Honeybee Radiance, is in basic properties under sensor grid. So we drop that down and connect the base geometry and take the outputs from the LB generate point grid and connect them to here. So we'll take points to positions, vectors to direction, mesh to mesh. And we just want to make sure that the base geometry is connected and it's the same geometry used to generate the points and then to create the sensor grid. And that's all you're really doing to create a grid. We can visualize that grid in Rhino. So let's turn the preview off. And actually, we have to turn all our geometry off so that we can see it a little bit better. If we turn our preview off and select just our mesh grid, we can see all those points. And then they're not visible here, but they are visible if you select the other one. And once we've confirmed that, we're kind of good to go. We can move on to the next step. The next step for both models is to connect the Honeybee model that you've created for both workflows and connect it to the grids. To do that, we're going to go back to the Honeybee Radiance tab, go to Basic Properties, and we're going to select the Assign Grids and Views component. Now this component, the first input is the model. So you want to connect your model to there. And because this is a this is a grid-based study, we're going to connect the grid to there. And we'll do the same thing for the other model. And so we'll take this model, take that model and this grid. And now we're ready to start our daylight analysis because our geometry is set up, our grid is set up, and I'll see you in our next video. Thank you so much for watching.